In this lesson, we are going to look at calculating the value of an ordinary annuity. So, an annuity is a series of payments or deposits at regular intervals. So, an ordinary annuity, the payment is made at the end of each interval. We can also have a present value of an annuity where we are withdrawing. So, we'll look at that in a little bit. So, you could think about it like this. Let's say you were depositing $500 for a year, and you're doing it every 3 months. So that means at the end of the year, you're going to be depositing $500 4 times. So the first deposit is going to earn interest. So what is happening is this original $500 that you're depositing is sitting in the bank for the whole year. So it's going to earn interest 4 times. The second deposit of $500 is being deposited in the second interval, so 3 months in, so it's going to earn interest only 3 times. And then the next deposit is only going to earn interest twice, and the last deposit would earn interest once. So the money that's sitting in the longest earns the most interest, and so forth. So there's very typical timelines you might see that look like similar to this that represent a annuity. We don't need this. So there is a formula given here. So the amount A is the final amount. So that's all the deposits plus the interest. R is the payments or deposit. So that's either your deposit or a withdrawal or a payment. I is the interest rate that we've been using in compound interest, and N is the number of compounding periods that we've been using in compound interest. So this is the formula. Remember that there is a formula sheet at the beginning of the course that has all the formulas that you need all on one page. So for example, Danielle's going to deposit $750 at the end of every 3 months, so that's 4 times a year, in a savings account. So every 3 months is the same as quarterly, right? Because you're getting it 12 divided by 3 is 4. So that's quarterly. 8% compounded quarterly. And we want to find the end amount. When you are using the formula, your deposit and your compounding period need to be the same, or you can't use this formula. There are other ways, which I will show you a little bit later, where we can use a TVM solver, and in it's used to be on the graphing calculators. We don't usually use graphing calculus anymore, but there are certainly TVM solvers online, and in a TVM solver you basically just type in the numbers and it will allow you to have a different compounding period than a deposit period. So for example, a bank might calculate your interest on your mortgage monthly, but you want to pay it weekly. So then they have to calculate what is called a blended interest rate, but we're not going to do that. There is a way to mathematically do that, and you could also use some software to do that, but we're just going to use examples where the compounding period will be the same as the deposit or withdrawal period. So we're depositing quarterly and we are compounding the interest quarterly. Okay, so the deposit is $750. The interest rate is 8%. It is being compounded quarterly. And N will be quarterly, so 4 times a year, and doing this for 10 years. So N is going to be 40. Subtract 1. And then this, let's erase this here. This is going to be divided by, it doesn't matter whether you do it all in brackets or outside the brackets, the 750. And this is going to be divided by the interest rate. So like I said, you could do the top bracket, divide by the interest rate, and multiply by 750 last, or you could do the top bracket, multiply by 750, and divide by the bottom. It doesn't matter the order, because order does not matter when you're multiplying and dividing. So I could type this all into the calculator, and the final amount is $45,301.49. So the question says find the amount of the annuity. Well, this is the amount of the annuity. And then it wants us to figure out how much interest was earned. So remember that Danielle is depositing $750 every 3 months, so 4 times a year for 10 years. So she's depositing $750 40 times. That is a total of $30,000. So she has deposited $30,000 of this $45,000. So the interest that she's earned is going to be the final amount. Subtract the amount that she deposited, and so the interest that she's earned is $15,301.49. Okay, so the $45,000 is not all interest, it is the amount of money she put in plus the interest. We also have present value of an ordinary annuity. So present value happens when you want to make some regular withdrawals. So let's say you win the lottery and you want to make some withdrawals later on down the road for the next 10 years. Or let's say it's a pension. So you're receiving a certain amount of money for a period of time. So present value, R, is the payment or withdrawal. And then I and N are similar to what we just used in compound interest. So for example, Kat has won a lottery. She wants to deposit some money in a bank account now, so that later on down the road she can take out $1,000 at the end of every month for 10 years. So if she had $100,000, she's taking out $1,000, but the rest of the money is still sitting in the bank earning interest. So that's why we have a different formula to account for the interest that's being earned while the lump sum of money is still sitting in the bank. So this is the formula. Okay, so we want to know the present value. So what lump sum does she need to put in so that she has enough money to withdraw $1,000 for 10 years? So she wants to take out $1,000. The interest rate is 6%. It's going to be compounded monthly. N is going to be monthly for 10 years, so N is going to be 120. And then we're going to divide by the interest. So if you calculate this on your calculator, type it all in, the present value works out to be $90,080. So think about this. She's taking out $1,000 a month, 120 times. That totals $120,000, but she only needs to put in this lump sum to take out that 1,120 times. She does not have to put in 120,000 because, like I said, if she puts in 90,080 and the first month she takes out $1,000, now she has $89,000 and $80 in the bank, and that is earning interest until the next time she takes money out. So although she wants to take out 120 times, she doesn't need that total amount because she's earning interest as the money is sitting in the bank. Okay, so there are a few questions here at the end that you can practice on. Questions, so you can try them out if you want some extra practice. And then again, as always, let me know if you have any questions about these. And then on the very last page are the answers to those